So good evening, and it's the same city. I'm not sure where the slides are. But a little bit different using, so... Weißt du, wo die sind? Nee. Ah, da. Kannst du das mal machen? So perhaps it's a little bit different that two people are here, but we started in 2010 together with this project, and it is a little bit divided in two parts. And so I will introduce in the project, then Daniele will introduce you in the first part, and then me in doing the second one. So we are working for Professor Gerd Hausladen. He is chairman at TU Munich, or because he's retired now in 2013, and we are working in his employment in Kirchheim and in Munich, and we are doing this project together with him in Rome at the German Academy for Arts. So it's an institution for artists, 10 artists per year from the German government sent it to Rome to do their work there, to getting very creative. And they had a little bit problems in 2010. Thomas Herzog, who was professor at TU Munich as well, and he was living in the Villa Massimo for 2 years in the 1970s. And together with him, we were looking for the problem they have with the comfort as well as with the energy consumption. So. You can see here this is a property. The first is Portineria, is where you come in, so that's not so important. Perhaps number 2 is very important. It's the main building. It's the administrative building of the Villa Massimo, and all this area is built in 1910 by a German industrial man who funded this academy and who gave Germany a lot of money to build these buildings, as well to fund the artists for several years. So we are still living, I think, from this money. And now we want to make this academy and this property, all in all, not only one building, to a zero energy property. You can see the research project part 1 and 2. Part 1 was starting in 2010, and it was more about the methodology, working in buildings with a very historical issue, and working on technologies. They are still in the building. So it was not the aim to have the zero energy, it was more to get better comfort and to think about how can we deal with these buildings. Part 2 is what we are doing at the moment, is because this project went another way, and then the German government wanted to have this as a pilot for to show in Italy that we are on the right way, perhaps in Germany, but we have to deal also with a very hot climate and with our buildings in the non-German countries or in Europe.
So the goal of the first part, which started 2010, was actually to develop a strategy how to deal with historical buildings. As Elisabeth said, Villa Massimo is a complex which was built in 1910 and 11, so it's not really very old, especially considering the place, the location where it is. And we developed a strategy how to deal with historical buildings. So the main goal was, on the one hand side, to reduce energy consumption, and on the other hand side, to define a methodology how to deal with historical complexes. So the main issues were the climatic conditions to be analyzed, to consider the building as a whole, so made of architecture, made of materials, building envelope, significance, so identity, and the building installations which were already installed, since Villa Massimo was completely refurbished about 10 years ago. So the problems, the comfort conditions were decreasing after the interventions of 2000, 2003. So the goal was to individuate and to evaluate the comfort problems or the critical aspects, and to develop energy to switch, to develop strategy to switch on renewable energies. We made a quite long analysis, and we made models which were validated by simulations, and maybe I'll show you some pictures of the complex. This is the main building with the administrative part and the representative part. It has a more complex profile because it hosts very different functions and has completely different load curves in comparison to the other buildings. So that's the inside. The goal was, of course, to make interventions to reduce any kind of strong and deep intervention on the building itself. So the goal was just to optimize the existing installations, which were quite new, and to switch on to renewable energies. So we analyzed, of course, the existing systems and the existing functions and the critical aspects, which are overheating in south-faced rooms, which are the bad regulation of the existing systems. And then the other building, which is residential and almost residential building for artists, and they have a big space to live and to create. The main problem in this other building was the bad comfort conditions in summer, because there was no cooling system, and bad comfort conditions in winter. And these are images of that. They tried to solve the problem by putting some split units and by opening the windows, but it didn't. They weren't sufficient to achieve good comfort conditions. So we made quite complex calculations, because we didn't have any precise data about consumption, about which building is consuming what. So we had to do more qualitative analysis, which was then fostered by thermal simulations. So the idea was to cover the biggest amount of energy demand by renewable energy, and we had a very convenient orientation of this building and a convenient geometry of the roof, so it was possible to plan a PV plant on the building. And we developed two different concepts in the first phase of the study.
And then 2 years later, we got some money from the government and some more money than it was sought before. And everybody was saying, why do you do such a very small strategy? Because perhaps you have here the possibility to show that it is possible without any destroying the building or destroying this heritage, to show that it is here possible to get zero energy. And so this is the strategy we have now, and which one I have perhaps a little bit to explain how it is working. So we are, as a scientific consultant, we did the concept and the simulations, and we are the scientific consultants to our partners, which is an architectural office in Berlin. And we are all funded by the German government and two ministries. That makes it sometimes very, very hard to work with two ministries, but we have to deal with this. And one program is the program for energy savings in Germany, and the other one is the program of the ENOP, which means to have very innovative technologies. So one, we are funded for the strategy, and the other part is for really to implement new technologies in this property. So the goal is zero energy, and we want to have these points, these are the more important points, the integration of the solar panels in the architecture, and we can only have this area we saw before in the roof, so we have to come down with our demand and our consumption to what we can have by ourselves with the PV. Then we want to have the very high, to use when we produce electricity, we also want in this moment to have the highest consumption, so that we don't have to put too much into the grid in Rome. And this is why we want to use solar cooling. And there's the other part where we want to switch down these peak loads with very energy intensive technologies, fan coils, something like this, because we want to do it with more low X and to use environmental energy from the ground. So perhaps on the next slide. Here you can see how we want to deal these two parts together. On the left hand side you can see the accommodation building where we want to have these floor or wall cooling and heating, and it was for the basic strategy we were looking for was to have internal insulation, internal wall insulation, together with activated activated walls and a clay plaster to regulate the humidity, because as Daniele pointed out, there is no cooling system in the accommodation in the moment, and we want to install it, but we don't want to dehumidify the air by a ventilation system, which means that we would have a lot of energy consumption in the future, and this is what we want to avoid. So we wanted to make it more by materials. This is why we want to use a clay plaster. And in the main building for the administrative, it is more about technologies and to switch a little bit in these now heating and cooling by air. It is more now to the water system and to have the recooling by ground boreholes and using the groundwater. And the winter, of course, we need some insulation where it is possible in the roof, on the accommodation, and the vacuum panels indoor can help us in summer and winter, we pointed out. Then next slide was, this is the opportunity if there is not possible to use the groundwater, because we weren't sure, there isn't so much project in Rome using the groundwater. And of course, Rome is very difficult if you want to do new technologies, because you're thinking everything is possible, and then you go and ask, and then they say no PV, no groundwater, something like this. This is like ice storage, so you have artificial thermal storage in the ground. In the moment, it looks very good that we can have the ground boreholes as well as the PV. So the strategy is more expensive, that is, because we don't want to do this. Okay, next is, perhaps I go a little bit more. This is rainwater using, this is how it is looking and coming to the focus of this accommodation. Next one. And here you can see how we were evaluating our basic strategy, and then we got into deeper detailed simulations, looking on the context, looking on the building stock with the architects. Now the architects are installed and working on our concept to design now what we were thinking in theoretical and methodologies. And the next one, this is how you can see we were evaluating our insulation strategy, and here we see that we haven't to make insulation on the floor because of the energy consumption, but we have to do it because of the construction. And so this is why we choose now not to put the activated walls, we want to activate the floor. And for one example, we brought you some, next one, simulation here. And you can see that on the right-hand side here with the clay plaster, we're in a very good way to get into the comfort zone by cooling the walls and without dehumidifying the air. It's load and reload by this clay plaster in combination with natural ventilation by night. Okay, and thank you for your attention.